Hey everyone, my name is Billy Korando. Thank you for that exciting and I guess also a little bit terrifying presentation, Glenn, because AI is coming for us all. I think we'll really know the AI revolution is here is when we have like an AI speaker speaking to a bunch of AI programmed developers, and it's just...
They're already AI people?
Yeah. And it's just all powered by the same LLM, so it just doesn't even make any sense. Because like people kind of hear about how like some people like after ChatGPT was released, where people like set up like just dummy websites that are just powered by ChatGPT, and it's just nothing but ads, and then there'll be like dummy bots crawling through just reading those ads. So it's just like complete nonsense. So anyways, that's coming for us all now. AI is going to kill us all. Also, this leads to the last things Glenn was saying during his presentation. Definitely go to DevNexus. You guys are really lucky to have really one of the premier Java conferences here in Atlanta. Like it's not just like, oh, this is a great conference for Atlanta. Like it's really one of the top conferences. Like there's really no truly better Java conference in the world. The DevNexus is the top of them all. So definitely go if you can. And also definitely volunteer if you can. Conferences always need more volunteers, and it's a great way to get integrated with the community as well. So with that said, though, you're here to learn about Java 21. So first is like, anyone on Java 21 yet? Anyone hope? Who's here on Java 8? Okay, Java 11? Good. Java 17? Good. Okay, that's good to see. Good to see. Oh boy, wait. No one's on before Java 8, right? Oh no. There's always a few. You're not alone, even though it might feel a little bit that way. I'm sorry. Well, this is going to be some really great stuff. We're going to be, getting to maybe in about a decade where we're going to be already on Java 31 at that point, but you'll get to see it here eventually. So, also don't hate me, I am from Oracle. I don't know, I'll probably should update this. I'm not really on Twitter or X anymore. Unfortunately, it's not as fun as it used to be. Whoops, come on, there we go. So one of the most important information is please ask questions. Like I'm here to teach you about Java 21 or anything Java related. I'm not going to necessarily know every answer to your questions, but I will try the best I can. And if I don't know, I can try finding someone who does know. But definitely at any point, feel free to ask questions like in this presentation plenty of times. Don't feel bad if you're interrupting me. I'll be able to, resume where I was before. And you can get this presentation right at this link, so don't worry too much about writing down like links and stuff like that. You can actually follow along right now with this presentation if you want to as well on your own machine. And if you would like to know more, I'm part of the Oracle Java DevRel team, and we have some great sites. We have our dev.java. And then actually back in September when we launched Java 21, we also launched the Java Playground. So there's some of these cool new language features you want to try out and don't necessarily want to have to go through the process of downloading Java 21 and installing a machine or something like that because maybe you don't have the privileges or for whatever reason, you can go to dev.java/playground and you can actually experiment with these new Java features. There's also insight.java, and so that's where a lot of our engineers, when they make a post about whatever deep engineering topic, we make sure to promote it there. So that's a good view into the engineering aspect of Java. We have our YouTube channel where you see me drink from an empty mug sometimes on some of my videos. And we also have our Inside Java podcast. So great ways to learn even more, to cover more than I can cover here in this presentation. So for this agenda, we're going to do a quick review from Java 11 to 17, though it looks like a lot of people are already on 17, but still it helps set up to where some of the new features are coming in 21 and beyond, building that whole story out. And then, of course, from then, we will actually get into from 18 to 21, and then we'll even look into some of the new features coming down the line, because there's still a lot more exciting stuff happening in Java. Indeed, in many ways, it's even more exciting. All right, so key changes from JDK 11 to 17. Text blocks, those were added in Java 15. And also, so you see here that says JEP. JEP refers to, that is not what I wanted to do. There we go. So JEP stands for JDK Enhancement Proposal. And what that is whenever there's a somewhat substantial change made to the JDK, it goes through the JEP process. And so like this is JEP 378. If you just simply go to openjdk.org/JEPs, and I was to do 378. That will take you to a whole nice document explaining the background, the goals, the non-goals of this change. So there is some feature I'm talking about that you want to know more about. Definitely check out openjdk.org, JEPs, and then the JEP number to learn more about it, because that's going to give you more depth that I can kind of go into for any of these changes to here. While the same text blocks added two-dimensional strings. Even this simple JSON message, if I was to have to write it out just using standard, one-dimensional strings, I had to be escaping these double quotes. I would have to be adding new lines. I would have to be adding tab characters. It quickly becomes completely illegible, or very difficult to read at least, and also very difficult to maintain because it would be very easy to forget a comma or anything like that. So text blocks just make it very easy. What you see here is what you would actually get when the JVM actually renders it. It's a huge improvement for when kind of working with any sort of linked JSON, HTML, SQL, and so on. A huge improvement there are any sort of large formatted strings. Switch updates. This was added in Java 14. Switch updates, they added the new arrow syntax, and that just can make it a lot more clear when working with a switch. Instead of having to include that break statement within every case to prevent fall through, an arrow only executes code to the right of the arrow. And along with these switch updates, along with the arrow syntax, is also the inclusion of switch expressions. So in this case, this is just a statement I am just printing out, or doing a system printout. Here, I'm actually yielding a value out of these. So in this case, if case 1 is matched, then the value of Sunday is yielded today. Switch expressions need to be exhaustive. So in almost all cases, that would mean you would need to use a default. The only example time you wouldn't really need to use one if you had an enum where you covered all the different enum values within the switch. But we'll see here in further updates to switch in JDK 21 how that has also changed a little bit. Seal classes, these were added in Java 17, JEP 409. And seal classes allowed a way of a class defining who can extend it. So here we have the class of user, and it's saying only admin, customer, and guests can extend off of it. And I found this can be very helpful. Before I became an advocate, I worked at various companies where you would have certain domain concepts, a transaction type, a agent type. So before I became a developer advocate and just a fancy haircut up here speaking before you, I did also work as a back-end developer. And every organization, we all have certain domain concepts like transaction type, order, user type, and stuff like that, where there's only a limited number of different types possible. And before, you would just kind of maybe have that in comments, or you would just have that explained to other users, oh yeah, so our place, there would only be 2 or 3 different transaction types or something like that, but there would be no way to actually define that in code. And now with sealed classes, sealed hierarchies, you can do that. So here with user, using the optional permits clause, I am saying only admin, customer, and guest are valid classes that can extend user. Now, when you define these classes, they are then obligated to either declare themselves as either non-sealed, and actually non-sealed is the first case of a hyphenated Java keyword, and a non-sealed class is basically a normal class. Anything can extend customer, or anything that has visibility to customer can extend it. There's final class, which is of course meaning, that's nothing new, nothing can extend guest, or a class can also be declared sealed itself. again. And in this case for admin, I'm saying there's either a normal admin or a super admin. You notice here I have using permits for this sealed class, but not here. Permits is optional for when you're defining or when you're referencing classes in a different source code file. You would need to use permits to say, okay, these classes in these other source code file are valid to extend off of it. If you define classes within the same source code file as a sealed class, the compiler will automatically assume that these are the only classes that are allowed to extend off of that sealed class. So that's another way. It's a good way if you have two very simple class or a limited number of simple classes. Instead of being forced to define additional code files, you can just include them all in the same code file for convenience and cleanliness.
Question.
Yes.
So when would you use final and when would you use seal? Are they interchangeable?
No. So final would be just saying nothing can extend guest. There's nothing you can do that would extend it. Seal would be a case if there is some things that could extend it, but you want to define who can extend it. Yeah. Any other questions? Yeah. Great question. Yes.
Can you use reflections to unseal a class?
I don't know offhand. I don't. Yeah, I'm not sure. Yeah. Sorry. Records. So these were added in Java 16. Then their JEP is 395. So records, they are a way of providing like a simple or transparent modeling of data as data. Of course, like the first way as developers will see benefits from records is the vast reduction in boilerplate code. So for many data objects or data classes that we kind of work with, we can simply define it all in a single line. But we can accomplish this is because and then from this we'll get like hash code to string and equals, as well as accesses for all of this. However, there are some constraints with records. They can't be extended. Their superclass or record is always going to be Java lang record, and it's implicitly final. It's only shallowly immutable, which means that, of course, I can't change the references to these, but if for one of these was an array or a list or something like that, I could potentially change some of the values within that list. So you would want to make sure if you're working with some sort of component or field within your record that could be mutable, that you would want to do defensive copies as it's being added into the record to make sure that you're not going to have something else potentially changing the value of a field within that record unbeknownst to you. Also, as mentioned, a record cannot extend or cannot declare an instance field. So these are the only fields, first name, last name, title, Twitter handle, that are valid for this record. So that way you can just look at the declaration of the record and immediately understand everything there is as far as what's going to be contained within that record. As mentioned, hash code to string and equals are all automatically generated. But of course, also keep in mind that there could be some instances where you want to perhaps override this. Again, using the example of perhaps an array or a list, the default implementation of hash code and equals, they're going to do a comparison based upon the reference value for that array or for that list. And that might not give you the correct equals you're expecting because let's say I have, instead of declaring each of these strings as individual fields, I just had like a list and that. And I did a comparison with it. If it's not the same reference list, it would come back false, even if all of the elements in that list were equivalent values. So in that case, if you're using something like a list, an array, or something like that, you will probably want to overwrite the hash code or equals to make sure you're getting that expected return for equals or hash code. Pattern matching for instance of. So pattern matching is becoming a bigger story within Java, but I started here with pattern matching for instance of back in Java 16. And so yeah, when working with instance of, which isn't necessarily super common, but here we have some sort of object that's likely some sort of number type, we can simply just say, okay, if it's a number type and it's instance of integer, then if this is true, this predicate is true, we'll assign it to the pattern variable of I, and then within the if, I can work with that I variable to, do whatever business logic I want to be done with it. What's also nice is this pattern variable. It's called what's flow scoped. And that means for the compiler, this is only in scope wherever the compiler definitely knows this has been set. So if I was to actually reuse I in this if block as well, that would be considered two separate variables to the compiler because these will be in different scopes. And we'll see a little bit later when we get to pattern matching, for instance, of how that flow scoping is actually really nice, so you don't have to necessarily come up with arbitrary variable names. Some API updates. I guess really the biggest is the enhanced pseudo-random number generators. So we had like splittable, jumpable, arbitrary leapable. So we had like all these different interfaces. Is there anything? Oh, okay, good. Okay, good. All of these different interfaces for generating random numbers, but the interfaces are all slightly different. So if you wanted to switch between them, you would probably have to do some different rewrites to your code, and it would be a frustrating and unnecessarily complicated experience. Now we have a common interface and make it much more interchangeable when working with them. And the underlying algorithms are also being updated to be more secure. For further updates, I need to update this link pointing to JDK 20 instead of the new hotness of Java 21. But the JavaDoc team has been continually working to update the interface and usability of JavaDoc. And here we go here. Let me go ahead and update it to 21. But we can see here, we can show these checkboxes to where we can say, oh, I only want to know what was actually added in Java 21, and it can narrow down that criteria. Or maybe you're going from 17 to 21, you can also, click these different checkboxes to see, okay, these are the new things I need to become familiar with as we're moving between that. This is very nice, it's very usable if you're going from, of course, like 11 to 17. Again, obviously, you can check whichever box makes sense for you. And there's also been a bunch of changes. The search has gotten a lot better. We even had just like a deprecated as well. The JavaDoc team is doing a really great job of updating the API and the presentation of it to make it a lot more usable, to be able to find kind of the content that you're looking for as well. So definitely check that out. It's a good way of exploring what has changed within the JDK between two arbitrary releases. For runtime features and improvements, GTC, it was initially released as an experimental feature in JDK 15, and then it became a production feature in JDK, or it was an experimental feature in JDK 11, and then released as a production feature in JDK 15, which is up 377. It's ultra low latency with sub-millisecond pause times, and oftentimes is actually well below sub-millisecond, often about a quarter of a millisecond or 250 microseconds. It's also scalable up to 16 terabyte heaps, and actually that pause time remains consistent as well. So even if it's working with like a 8 terabyte heap, you would still maintain a sub-millisecond pause time. Actually, so it's single generation with ZGC, but actually became a multi-generational garbage collector in 21, and I'll get to that in a few moments. But definitely check it out. Just plus use ZGC, and then also some great videos on it as well. Helpful null pointers. We all hate null pointers. We've all experienced that pain of that null pointer showing up in your logs, and it's on some line where there could be 4 or 5 different values that could potentially be null. With helpful null pointers, it will actually say, oh, this is the actual variable that was null, that shouldn't have been. So it can really maybe save you that pain of potentially having to do 2 production pushes, 1 production push to add arbitrary logging to say, okay, this is the null value, and then the second push to actually fix it. Well, now you only have to do that 1 push because you're going to get a much better idea of what was actually null. Now we support ARM Architecture 64 support across all the major platforms as of JDK 17. And of course, we continue to work to further support it with every release as well to get even better performance when running on ARM Architecture 64. Some deprecation removals and changes. So a big part of being good stewards of the Java language is also knowing when we need to kind of trim some stuff back. Two such are the Security Manager and the Applet API. So how many people here have used the Security Manager? One. I've always found that no matter how big the room or how small the room, it's always like one person. Actually, surprisingly, I had two people in a really small presentation I was giving. That's always generally the way it goes. But anyways, the Security Manager, you might be thinking, oh my God, Java is getting rid of the Security Manager. It's becoming less secure. Well, the reason we're getting rid of it is because we're also getting rid of the Applet API. So the primary benefit of the Security Manager is a way of having at the package level and other levels control of saying like, okay, or JDK or JDK.java.ling, whatever, that has E and all privileges, but bk.org, whatever, that's going to have very limited privileges. And that made sense when you're running with applets, where you're bringing in this extra code to run on top of your already running JVM. But of course, we're not doing applets anymore. So all the code that's running on your JVM was code that you actually built. Now, maybe you're bringing in a third-party library, but if you're worried about the security of that, we want to be doing that with static code analysis and checkers like that. You want to be doing that at runtime. And so really the best way to make sure your code's secure is to be using operating system level constructs to say like, okay, these applications don't have access to write to these file folders or don't have access to write at all or can't make network connections or anything like that. That is how you would be doing the security, not with the Security Manager, Applet API. I'm sorry for all the Applet developers out there, but yeah, that dream is dead. And so eventually this will be all removed here at some point. Of course, that's ongoing because there are some valid APIs that are still useful in other contexts besides security. So that's kind of ongoing how we're going to particularly deprecate and remove the Security Manager. So some removals, the Nashorn JavaScript engine. Despite the name of JavaScript, obviously between Java and JavaScript is about related as a ham and hamster. So fundamentally just trying to run JavaScript within the JVM just was too many issues. So it was removed. Nashorn is still out there. We have like that within our GitHub and it's occasionally updated. So if you want to still use it, you can build it and then, run it within your JVM, but it's no longer actively developed and supported. The CMS garbage collector, fundamentally the G1 garbage collector, is an upgrade, an improvement over it, so it has been removed as well back in JDK 14. Other changes with JDK 17, that story that we started of encapsulating the API that began with JDK 9 and the addition of the Java module system has kind of really come full circle, and now we're no longer illegal access permit is even a valid argument. So if you need to have access into a particular module, you will actually have to use the add opens to do it. We're no longer giving you that escape hatch that just allows everything out of there. But, I know there was some consternation, I think, when we released JDK 17, but really haven't heard much about it since then. So it seems like it's gone pretty well. All right, so now let's get into JDK 21. Any other questions between JDK 11 and JDK 17? Okay. So yeah, the pattern matching story has now continued. So now we have pattern matching for switch added in Java 21 with JEP 440. Pattern matching for switch. So when you're using pattern matching, it must be exhaustive, even if it's written as a statement. But yeah, so we have like a simple interface here with a bunch of different classes. And we can see here, we can, using pattern matching, if a triangle type, we can also have guard conditions where we can check like the area of the triangle and do something else. And if if it's greater or if it's less than 100, then it can drop through to the following case. Of course, this case can't dominate following cases. So if I would try to put triangle T in front of this or as a first declared case, that would be invalid. But this is a good way with the guard conditions of being able to keep everything about that test case or within the actual label of the case and not having like an arbitrary if statement within the body of the case as well. But as mentioned, like you would always when written as or when using pattern matching in switch, it would have to always be exhaustive, even if written as a statement. We also now support null as well. So before, you would often have to put either a if statement before saying like if null, you would have to handle it separately, and then you would go into your switch. But now switch can handle null as well directly, and that's just a better way of handling instead of either having to deal with an NPE occasionally coming or null pointer exception coming up. You can handle directly within the switch instead of in a if statement before. But also because switch can already handle a null condition, it's not part of the exhaustiveness check to your switch statement or to your switch. Lastly, so I mentioned or we talked about sealed hierarchies before. The compiler can actually read that sealed hierarchy, and from that it can determine if a switch is exhaustive. So because within the switch I'm covering all of triangle, circle, and square within here, so that's the only 3 valid classes that can extend or that can implement shape, I don't need to put a default case within there. And that's very nice because instead of having to use perhaps unit testing to make sure you're covering like all the different potential permutations going through that switch, you can actually have that much more greater guarantee at the compiler saying, no, you're actually covering all the potential cases within this switch. And if we were to add a final class pentagon to this, then you would get a compiler. You can even build the code because you're not covering it in the switch then. So that is a very nice, safe addition. That's like a big thing that a lot of these new changes with pattern matching and records and stuff are adding, is adding a lot more safety into your code when they're actually used. On the subject of pattern matching, we also have record patterns, again, added in Java 21 and JEP 441. If you're kind of wondering, if you were following the development of like pattern matching for Switch and you're kind of wondering why it went through like 4 rounds of preview, the big reason was we're trying to get the integration between switch patterns and record patterns right. One of the nice things about the new previewing features that we're doing is it gives us a chance to get that feedback from the community before we actually agree and put an API into a finalized form, because we kind of experienced like some of the pains of that with like serialization. If you're very familiar with serialization, that has caused a lot of pain within the Java language over the years. But now we actually get a chance to have some feedback from the Java community to make sure we're getting a new feature right before we say, yep, this is it, and this is it forever, and now we have to support it. So record patterns, it's a way of basically being a deconstructor. So we have a constructor where, of course, we define a way of creating and adding data into a new instance, and deconstructors are just the opposite of finding ways of getting data out of that instance. So the record patterns, they just go by the position compared to how the record was defined. So this can make a great case for like using something like var to easily reference saying like, okay, as long as like what you define here, what the type you're defining is valid for that position, then that matches for the record. So it can make var very useful to use here. As mentioned, record patterns can also be used within a switch statement. So we can see here, name, and then pulling that data out of it to then use in the case as well.
Is there a typo in that when middle name is not should it be M name?
Yeah, that's a typo there. Sorry about that. I thought I had an example of this, but I should also mention that you can also do nested records as well. Let me see. I have an example of that. Yeah. So here you can also nest record patterns. Let me full screen that. So yeah, you can also nest record patterns. So here, like we have our name, then we have an address, and then we have the person, so which is a combination of the name and address. And if I just wanted to drill down to get the values out of name, I can also do person, name, and then get to the values there. The dot dot dots here, that's just saying I'm not concerned with that in this example. So that's a simplifying example there.
But you still have to provide it, otherwise the pattern won't allow it.
You still have to provide it, and we'll actually see how that's going to be a little bit easier here soon enough with unnamed variable and record pattern types. So yeah, those are the two big language changes between 18 and 21. For the API updates, really nice change is the addition of sequence collections, and that is JEP 431. And sequence collections, it's a way for sequences that have a defined order of like doing something like getting the reversed of that sequence, or getting the first or getting the last, because before, if you wanted to get, say, the last element out of an array list, you have to get like size of the array list -1, which is just, again, doable, but frustrating. If you wanted to go reversed through a list, like that would be an extremely painful process. So yeah, long overdue, but very nice that it is now finally here. So there's sequence collections, then there's sequence set, which is just for the reversed overriding it to return a sequence set instead of just a sequence collection. And then there's also sequence map, which has reversed as well as getting the key set, value set, and then just also the appropriate language for the different type of collection. But to see how these actually fit in with the overall collections hierarchy, we can just see we just added these new interfaces at the appropriate level. Particularly noteworthy, so because like things like an array list are pretty common when using a list, of course that is covered under the list, and an array list has a defined order. But because like something like a hash map, that's pretty commonly used, but it doesn't actually have a defined order, because hash map actually implements directly off a map. So if you are using hash map in areas and you want to take advantage of sequence map, you would have to use some sort of different implementation like a linked hash map or a tree map or something like that. Okay, so yeah, by far the big and most important change was virtual threads, and that was added in JDK again 21 with JEP 441 or 444. For that, I also again want to go to another little presentation. So go away, whatever. Within Java, everything runs on your thread. So from your hello world program to any other methods that are executing, that is all running on threads. Now, traditionally within the JDK, a thread has been tied basically on a one-to-one basis with the underlying operating system platform, and from there to the underlying CPU, that's kind of all a one-to-one basis on that. And so because of that, there's a relatively limited number of threads available. Now, if you're writing an application and you only need like maybe a few dozen threads, that's not really too much of an issue. But for many applications, like for many web applications, which often use a thread per request model, you can quickly run out of threads to where you can no longer support it and your application is going to be waiting until another thread is available. Now, on the face of this isn't necessarily that much of an issue if all those threads are being fully utilized. But the reality is, particularly again for many web applications, those threads are often going to be spending time idling while they're waiting for a response back from some sort of external service, database, some other web service, whatever it might be. So you're making that call out there, and the thread is just sitting there waiting and doing nothing until it gets that actual response back. Zooming out, if we look at the total JVM, you get to be fully utilizing the number of threads you can be using, but your actual CPU utilization could be very low because, again, many of those threads are actually spending a lot of time waiting while they're getting a response back from, again, whatever database or web service you might be calling. So Project Loom is separating that concept of a thread into two concepts: a platform thread, which is basically the equivalent of your normal thread, and so it still has that same basically one-to-one relationship between the underlying operating system thread, and then goes on to the CPU thread, and then virtual threads. So both of these extend or are Java Lang thread. A virtual thread exists only in memory, and it runs on top of your platform thread. And then the JDK is able to handle the scheduling and unscheduling of those threads. So the default is the fork join pool, and it will take these virtual threads and then run them on the available platform threads. The default behavior is FIFO, first in, first out. So the first virtual thread that's available, it will be put on, and so on. So what it can do, though, is it's able to detect when, like, you're making a call out to some sort of external service and saying, like, okay, it is paused for now. And if there's another thread available that needs to be run, then this can be parked in the fork join pool, and then the JDK can start and run that other thread. So now your JVM and threads are being more fully utilized. And then the JDK can listen to see if you're getting bits received back on the socket that thread was listening on. And when it does, then it knows that, okay, the next time that thread has an opportunity to be run, it's going to put it back on there to be executed again to continue its work. What is nice, though, is that the virtual threads are not tied to any particular platform thread, so they can be run on whatever platform thread is available, but the context of that virtual thread stays with it. So the variable thread, the thread local values, the stack, and all of that sticks with that virtual thread, not with the underlying platform thread. So basically, you're getting pretty much all the benefits that come from like reactive design, of that highly horizontal scalability, but you're not having to deal with the frustrations of reactive programming, where it can be very difficult to reason between, like, okay, I'm getting an error here when I'm calling like a database and got a response back. How does that connect to this request? Because that connection can often be broken within a reactive design. You're getting the same standard imperative blocking that we're familiar with, but with that same horizontal scalability that you get from reactive design. So very nice. Now, not necessarily, it's not like magic Pixie does that's going to make your applications run fast or anything like that. If you're not getting to the point where you're limited by threads, you're not going to see a benefit from it. Actually, when we did a launch presentation on Java 21, we brought in someone that was already using some Java 21 features, but he actually wasn't seeing much benefit from virtual threads because he was CPU bound, not really thread bound. So because he was doing like a scheduling application, so he didn't really get much benefit from virtual threads. Which is to say that this is not magic, Pixie dust. This is going to make your applications perform faster. But for many of us who are running on web applications, you should notice a pretty good benefit from it as you move to it. And of course, your underlying frameworks are also able to take advantage of it.
Can you comment, if you can, on the, like, what's the integration with the string API, especially with, let's say, Babel streams? Could they use, can they use virtual threads?
I'm not quite sure offhand the integration, and like if you would have to, as a developer, actually reference a virtual thread or not. I can't give a good answer there. Any other questions about virtual threads? Because obviously I realize that's deep. Yes.
Yeah, so if you declare a virtual thread and that thread is blocking because you're making an API call somewhere else, would that affect the, I guess, the platform thread and make that wait?
Not the platform thread. So, like I said, the JDK is if there's no other virtual threads are needing to be run, then that virtual thread will stay on that platform thread and wait until it gets a response back. But if there is other virtual threads available, then the JDK can say like, okay, you made a blocking call, because like it detects it based upon certain kinds of different calls that are known to be blocking calls, and says like, okay, this has been called, and it can then park that virtual thread into a pool, and then take any other virtual thread that is ready to be starting to execute again, and then put it on an available platform thread. And again, the way the JDK understands to know like, hey, this virtual thread is ready to be executed again, is that whatever socket it's waiting for to get a response back from, saying like, okay, this socket is starting to receive bits again. Okay, it's ready to start to be executed again.
Okay. And so,
sorry, no, go ahead. No, go ahead.
Yeah, so the platform thread isn't necessarily going to be something that you control yourself. Would it be just when we ever create a thread, they're all going to be virtual threads, so they could put on top of the platform thread?
I mean, you would have access to be able to create your own platform threads, but you really should never do that. You should always be creating virtual threads, because the actual, I don't have it on here, but like the actual size of a virtual thread in memory is only 4 kilobytes. So there's just really never a benefit to creating a platform thread. So yeah, you could create a platform thread if you wanted to, but you should always just create a virtual thread and then allow the JDK to be able to run that on whatever available platform thread there is available. And by default, like the number of platform threads that the JDK will create will be based upon how many underlying threads are from the CPU, which I think is a 1-for-1, or how many cores are available on the underlying CPU. But you can also configure that to be some other multiple, like, oh, okay, I have a 4-core system, but I want to have 4 platform threads for every core. So, through a system configuration, be like, okay, then I'll have 16 platform threads, something like that. Yep.
If we're already using like a thread pool for the platform threads, would this replace that thread pool, or would you have a thread pool for those threads and a thread pool for virtual threads as well? You
would never want to put virtual threads into a thread pool, because like you're not really getting any benefit out of them for that. And yeah, you would probably want to, when moving to JDK 21, like there wouldn't be necessarily a negative to having a thread pool, or you would want to get rid of pools or thread pools, just because the JDK will be actually managing those threads instead. So you would no longer be getting the main benefit of thread pools that you would have had before. So
when updating to Java 21, you're saying to like phase out thread pools?
Yes. Yeah. Just because you're no longer getting, because now you're no longer really thread constrained. Because like the reason you have a thread pool is because you're thread constrained. Just kind of like you have a connection pool, you have a limited number of connections. So as like a thread is no longer in use, like a connection is no longer in use, you would want to switch that out to be fully utilizing it. But now the JDK itself is handling that effectively as a thread pool through your platform thread. So it's like, it's not a regress or anything, but you're just no longer getting the underlying benefit from using a thread pool once you move to JDK 21, because threads are no longer constrained. Yeah. Yes.
So with thread pool, you kind of naturally get the throttling, right? You cannot run beyond
Yeah.
the pool. So with the virtual thread, is there any way to do throttling, to turn the throttling or the back pressure? So like say if you want to overwhelm the downstream services that you're calling, right? Because you can just with virtual threads, you have thousands of them, running at the same time. And if they are pretty much all IO bound, they can circle through very quickly.
Yeah. So where you could be overwhelming it. Yes, I guess yeah. Yes, there's a way. I don't know offhand the API of doing that, but yeah, there would be a way of bounding it to where you're not going to just, the database you're going to call, you're not going to just all of a sudden like boom, 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 like this. You have like thousands of calls going through and just completely overwhelm that downstream database. Yeah, there will be ways of limiting, either directly to the virtual thread pool or just in your application code, limiting the number of calls you're going to be making to like that downstream service so you don't overwhelm it, or you maybe would have on that downstream service a way of saying like, oh, okay, I only can handle like 5 calls that, within a 30-second frame, we're going to pause on taking any more requests until I actually, get some of these requests completed. So, yeah.
I have another question.
Yeah,
So
absolutely.
will there be visibility into the virtual threads and like the visual VM? Do you know?
So yes, eventually. I think some of these tools, so before, like you would only have dozens to maybe like a couple of thousand threads at most possible within a JVM at the same time, because otherwise you would kind of get run out of memory or you would overwhelm the underlying CPU with all the concurrent threads. So like things like Visual VM and other tools that let you visualize those threads kind of took that into consideration, that there was a relatively limited number of threads. Now with virtual threads, a JVM could easily support millions of concurrent virtual threads. And so some of those tools, I don't know if they've really been fully updated yet to properly handle that potential large amount. I think many of them can already support virtual threads. It's just like really like an additional property that would be shown on the virtual thread, saying like, okay, this is a virtual thread ID and this is like the platform ID. If you're to like do some logging on it, like it will say like, yeah, virtual thread ID and platform ID, just so you know where that's running from. Like I said, I think that can be sometimes like the issue with some like Visual VM, JDK Mission Control, about being able to support potentially millions of concurrent threads at the same time. So that's about the only issue with them. Any other questions about virtual threads? If not, if you think of a question later, feel free to ask. So runtime features and tools. Something we don't talk about enough that's actually going to become really important here, so I'll just get to it in a second, is class data. How many people have heard or how many people have heard of CDS? Oh, that's too bad. So CDS did stand for class data sharing. They're using a different acronym now because that's no longer quite accurate. But basically, it's a way of whenever you start up a JVM, the JVM is going to be loading some classes out of the JDK or also your application classes as well. Of course, every time you're starting up that JVM, it's just going through that same process every single time. So that's obviously an opportunity for an optimization. So what CDS does is creates like a pre-processed archive that it can load from, which can then help improve startup time. It will vary depending upon your application, but like maybe 10 to 20% faster. And they've progressively made updates to it to where now with JDK 19, you can get, with like a single argument, being able to use -XX plus like auto-generate CDS archive, to where that CDS archive isn't available, it'll generate it. And if it is available, it'll just load it. So it's very easy to use. I have like a article on it, but it's definitely worth checking out for a very easy and safe way to improve the startup for your applications. Where CDS is going to become even more relevant, though, is that Project Leiden. How many people have heard of Project Leiden? 1, 2, okay. So Project Leiden is a new project that's just starting to get going for JDK about improving startup time for your Java applications. And CDS is going to be kind of a major basis for it, about, again, already what I talked about having a pre-processed way of loading all the classes that application is going to be using, but then also including things like ahead of time compilation, ahead of time optimization as well. So it's going to be very nice because I was just looking at a presentation by one of our engineers on using Project Light and some of like their early demos of it, and like using like the Spring Boot Pet Clinic test application, where on his machine it was taking about 4 or 5 seconds to load. It was getting to a sub-second startup time as well. So CDS, a lot of people haven't heard of it, but it's going to become very big here in the next few years as Project Leiden starts to gain steam and the story about improving startup times in Java starts to become much more of a mainstream story within the JDK itself. Oh yeah, so yeah, that's the 2 arguments, X auto shared archive, and then the name of archive you're going to be using. So that's a good way you can put it within like your build system to create that archive, perhaps within your container, and you don't have to have like 2 separate arguments that you would, or 2 separate command line arguments you would need to have to create the archive and then use it like you had before. Definitely worth checking out, again, for an easy way to improve the startup time for your application.
You still need to create that file, that G.
1 second. So yeah, you would need to create this shared archive, but what this argument is doing is if this shared archive is not available, it will create it for you, and if it is available, then it will just load it. Yeah, and like I said, and then yeah, exactly, and then just what's nice about that is that with the if you have like your CI process building your archives out, like you don't have like a separate CI archive to have it build out the archive and have like a different command when you're actually running it. It's all the same command, so that way there's not having to maintain 2 different commands or having 2 things that are slightly different between your CI process and when you're actually running in production. Yes?
Is the archive also portable like the ARM, or is it specific to the machine?
No, it's as long as you're using the same platform, like as long as like you're building it on Linux and running it on Linux, then it will be portable. If you're using some sort of different platform, then it would have to be you have to build it for that specific platform. So yeah. And then also, I guess what's nice is like it's very robust. So like let's say there's something corrupted with that shared archive, then the JVM will just ignore the shared archive and then load it from the JDK or load it from the file system as normal. So that's also a nice way that it's not like, oh, there's something wrong with this archive, it's just going to crash. It's just like, okay, it's just to ignore it and then load it, because why crash it just to save a little bit of startup time. In JDK 18, we started offering a simple web server included in the JDK. I'm actually running this presentation on that simple web server, so that's very nice. If you just do JWeb server, it will then serve all of the files from that directory that you're running that command from. So like I said, I'm running this presentation from using the JWeb server. So pretty nice, easy win. And it's kind of one of the ways we are doing it to make Java a bit more accessible for students, because oftentimes an early lesson for students learning Java or any programming language is to serve up files on a web server. I mentioned GDC earlier, so that became a production feature in JDK 15. And now with JDK 21, GDC is generational. And so what that means is a generational garbage collector, when an object is allocated, oftentimes most objects become unreachable shortly after they're allocated, and then at which point the garbage collector will say like, hey, this is no longer used, and then it can reclaim that memory. So before GDC was just treating the entire heap as a single generation. Now generational GDC splits that into two separate generations, and it's done, like I said, as I mentioned, is that most of the time objects shortly after creation is no longer reachable, so that younger region is scanned more frequently by the garbage collector, so it's just being more efficient with the CPU. Instead of trying to scan the entire heap for objects that are no longer unreachable, it's only scanning a smaller section of the heap where there's going to be very likely to be a whole lot of objects that are unreachable. The biggest benefit to that is that there would occasionally be issues with GDC under very heavy load, like very, very heavy load, where they could run into allocation stalls and then the latency time could get a little bit longer. Generational GDC in our internal testing has really resolved that issue. Like at least an example, we're using Apache Cassandra, where after about 75 clients in our test case, GDC could start to really struggle in keeping up with the pressure, whereas generational GDC, even up to 275 concurrent clients, it remains very consistent in its pause times. Performance improvements, the actual reality of it between JDK 17 and JDK 21, the story is a bit mixed. In some areas, I think footprint is like a little bit less, but throughput got a little bit worse in some cases. Measuring performance can always be very difficult because, I know in many areas, like a lot of our cryptographic algorithms got much faster, like in some cases, like 1,000 times faster than it was in JDK 17. But of course, if you're not using that cryptographic algorithm in your application, you're not going to see that benefit. So measuring performance is a bit difficult, but overall, it's like a bit of a mixed story between JDK 17 and JDK 21. There wasn't any big improvements, and in a couple areas, there was some regression. So overall, it's about the same, with maybe some areas being significant improvements and maybe some areas being more significant regressions, but overall, it's pretty consistent between the two versions.
What about 8 to 21? Is that a significant?
Yeah, it's a very significant improvement in most any area for performance. Deprecation removals and some other changes. The only major deprecation is the Windows 32 x84 port is for removal, but this really only matters if you're actually building the JDK itself, which I'm guessing not many people here are doing, or many people at all generally are doing, so probably doesn't really matter too much. All right, so now we're going to get into some of the cool stuff that's coming even beyond JDK 21, at least as far as actual final features are concerned. So I think you were mentioning about nested patterns, record patterns. So this is where unnamed patterns and variables come in. So this became a preview feature in JDK 21. And I believe it's actually going to be a final feature in JDK 22. But yeah, so here, I'm dealing with a nested record pattern. And really all I care about within all this is the billing address, but I'm kind of being forced to declare name, address, CC number, expiration date, and all that information. I don't really care about that. So instead, I can just use the underscore to say, I don't care about this. In the back end, the compiler is still kind of assigning a variable to it. But as far as to you as a user, it's a pretty clear indication saying, these variables don't matter. All I care about is billing address. So it's both easier to write, but then also for that developer in the future, when you've gone on to another job, they can read this code and be like, oh, yep, Billy, he only cared about billing address in this piece of the code, and that's why that's all that's being worked with. So that's a very nice way, and also, again, how it's also a little bit safer code as well. Don't know why that matters. Yeah, so also, let's see here. So it's a pretty arbitrary example. I just took this directly from the JEP. But here, I'm working with the letter I for something, and I'm iterating, I'm using a for each loop through names, but I'm never referencing the n variable. So instead, I can just do an _n. So it's not just relegated to patterns. It can be used in other arbitrary locations as well. It can also be used with exceptions. So like a very common exception where you have like an illegal argument exception, you're not really probably going to be using that stack trace or anything from that exception, but you want to, send a warning back or whatever it might be. In that case, you can then, again, just use the underscore to say, like, I'm not really ever going to do anything with this exception because I'm sending it back to the user saying, like, hey, you sent cat for your age, and that's obviously invalid. Structured concurrency, another change that's going to be really nice that also works together really well with virtual patterns, or virtual threads, now that threads are very cheap. Oh, okay, so, sorry, I should have actually had some code examples with this. But pretty much what structured concurrency lets you do is to break up a task into subtasks that can then be executed concurrently. So some of the examples like other people on my team have put together is like, let's say you have like a travel agency, and for the travel agency, you're saying like, okay, I'm gonna call like all the different airlines to get back plane tickets prices from like, so I live in Kansas City and I'm obviously here in Atlanta. So it's like, okay, we're gonna check like American, Delta, United, Southwest. We're gonna call them all. We can break that up to be executed concurrently, and structured concurrency allows you to be like, okay, we're not gonna continue on until we get responses back from everything. Or we're gonna continue on, once we get at least 3 responses back, maybe we wait a second and we don't get anything back, we're gonna continue on. If anything errors out, you can also handle that all in one block, saying like, okay, if there's one error, what do you do? If there's a bunch of errors, what do you do? It allows you to much more easily break down tasks concurrently than it was before. It's very cool. It's one of those, definitely there's been some cases where in my career where I've been like needing to call out like to multiple web services to where I would have to end up just doing it sequentially, even though it could be done concurrently, because there's just no easy way to do it concurrently at a time, where I really wish we had it back then, or structured concurrency at the time, because it would have made the code a lot more performant and a lot easier to work with. Scope values. So as mentioned, now with, it did actually, I need to update this presentation. So these both made it as previews in JDK 21. It's not a question mark. But scope values, so now that you might have potentially millions of concurrent virtual threads, if you have like some sort of value, so to go back to the example of like calling out to different airlines, like you might be saying like, okay, you're going from this location to this location in each of these calls. Like instead of having like a thread local variable for each of those calls, you can have a scope value that can be used for all those different calls without having to copy that value into each of those. So a scope value is saying, so this value is an immutable value that can be shared within this particular scope without having to have multiple instances of that value across all the virtual threads. Vector API. This is not really at all my forte. My background is a web developer, but basically the Vector API is about updating how to do like certain kind of math calculations within the JVM. And anyways, if you care about doing like image processing or things like that, the updated Vector API is going to be a huge boon and a huge improvement for that. But if you're not doing that, you're not going to care too much about it. So it's in its sixth incubator, and in JDK 22, it's already proposed for its 7th incubator. It's going to remain an incubator until Project Valhalla starts delivering on some of its goals, just because that's going to fundamentally impact the underlying API for the Vector API. So it doesn't make sense to finalize the Vector API until Valhalla starts being finalized itself. The foreign function and memory API, again, this is about Project Panama. If you're needing to work with native libraries, the foreign function memory and memory API greatly improves upon that experience. It's more secure and it's more consistent. And it's also, I believe, supposed to be a final feature in JDK 22 as well. I'm pretty sure even the Panama team has actually publicly stated as much. String templates. So again, it became a first preview in JDK 21. And this is something I really wish we had earlier for some projects I was working on where I was working with like large strings. But it's a much better way of saying like, okay, if I want to replace certain values within a string, we have a way of processing that string to insert those values. This gets a lot of complaints online about using the backslash and curly brace. And the reason that was chosen is because backslash curly brace is an invalid code sequence within a string in Java. And that is a way for the compiler to know, like, hey, this is a string template and not just a normal string. So that way you can't accidentally switch the two up. You can only, this is only valid to be used within a string template. So by default, there's two types of processors that are provided, string and format, but you can extend your own, meaning you're going to be extended like for SQL, HTML, and so on. But the reason why we're handling that all on their own processors is because like the rules around how you want to handle that is going to vary so much based upon context. And so rather than trying to cover all those contexts directly within JDK itself, we're going to allow the community to create those processors to better handle that for the cases as they are needed. And I think this is the last one. So unnamed classes and instance of main methods. So of course, when we all first started working with Java, this was our first program: public class hello world, public static void main, string, array string args, and then system out println. This is a lot here. I mean, again, all of us here, 2, 3, 4, many years of Java or decades of Java experience. But this is a lot to learn because you're learning about access with public, class, static, return types with void, arrays. So much is going on here. I kind of remember like a few years back thinking like, okay, if I was to talk to someone who has never done any programming, never done Java, like everything that's going on here, like it would take many hours to really explain all these different things. And by that point, that person is going to be like completely mentally exhausted from that. So oftentimes, when people are learning Java, their instructor, professor, or teacher, whoever it might be like, look, don't worry about these things too much yet. This is going to be your first program. So it becomes a bit like magic, like, oh, these are the incantations that you need a public class, whatever, public static void to, get your Java application working. Now, we can further simplify it down to where like we don't have to have a public class to be your main class, and main doesn't need to have public static in front of it either. You can further simplify it by saying even main doesn't need to take arguments, or it doesn't even need to be in a class either. So now it's a much gradual, Brian Getz, the chief Java language architect, put together where he calls it paving the on-ramp, to where it's a much more gradual, we can introduce new concepts as they become relevant to users, to them. But it's also really nice for even older developers, if developers are, already in it professionally, that Java is now becoming a much more practical language for writing scripts or, simple utility applications. Between this and ability of Java to launch single source file applications, and hopefully soon enough multi-class or multi-source file applications just with the Java launcher itself. If you want to write just like a really simple, like, hey, I want to parse like this Excel file or something like that, you can start actually using Java for that instead of, having to use Perl or scripting or something like that instead. But yeah, definitely check that out, paving the on-ramp. And then as mentioned, the launch multi-source file code applications is also a draft JEP, or I think actually it's been actual declared JEP now, but you can read that great article from Brian Getz on this link here. or you can just search paving the on-ramp Brian Getz in Google, and that'll bring you to it. So from follow-up links, in the lead up to the Java 21 release, myself and other people on my the Java DevRel team at Oracle, we put together a bunch of videos covering like going from like Java 17 to Java 21, like upgrade considerations, things like virtual threads, the new language features, and all that. We have a whole playlist, so definitely check that out. Kind of recovers a lot of what I cover here, but in much more greater detail. Check out the release notes, and again, check out inside.java and dev.java. With that, is there any more questions? All right, well, and then I'll also see you at the bar afterwards, so if you have any questions, feel free to ask me there. Awesome, thank you.